Hello friends, welcome back to the tetrahedron chemistry classes. So guys, this is my lecture number 4 on the IUPAC nomenclature of organic compounds. In the earlier 3 lectures, I have covered all the basic rules which are generally used to give a particular name to the organic compound, especially IUPAC name to the organic compound, and I have covered the complete, the full in-depth knowledge about the IUPAC nomenclature of alkane, alkene, alkynes. And in my lecture number 3, I have explained carboxylic acids, nomenclature of the carboxylic acids. And now today onwards, this is my lecture number 4, and today I am going to discuss IUPAC nomenclature of carboxylic acid derivatives. So there are generally 4 derivatives of carboxylic acid. First is the acetic anhydride, second one is the esters, third one is the acid halides, and fourth one is the acid amide. So I have written acid halides here, so I should place X instead of your Cl here, right? C, carbon, double bond oxygen, and X I am putting here. This is your vacant valency, and X could be anything, your chlorine, bromine, and iodine, right? And lastly, your acid amides are there. I have arranged these anhydrides in the same order in which they appears in the priority table. So after carboxylic acid, your acidic anhydrides would be there. And in today's class, I am discussing this IUPAC nomenclature of acidic anhydrides only. Say if you are new here and watching this video for the first time, and especially when you are in class 11th, then it is my personal advice to you, please watch the earlier lectures as well, because in the earlier lectures I have explained all the basic rules which are necessary to give the IUPAC name, and I am also giving you the link in the description box for the earlier 3 lectures, right? So without wasting too much of time, we quickly jump onto the IUPAC nomenclature of the acid anhydrides. So when I am discussing the acid anhydrides, please note that the functional group, so I am writing FG instead of full functional group here, so I am using this abbreviation FG. This is the functional group, and for acid anhydrides, your functional group look like that. Carbonyl, 2 carbonyls will be connected with the help of the this particular oxygen. So in the middle you are having the oxygen, and on the right hand side you have connected this oxygen with the carbonyl, as well as on the left hand side you have connected this oxygen with the carbonyl group, and these are the vacant valencies in which your alkyl groups or the aryl groups may be there. So this is the functional group. It is very, very important. See, these carbonyl groups are everywhere in the various classes of the compounds, in aldehydes, in ketones, in acids, esters, right? Everywhere they are. So it is very, very important for the beginners to clearly identify the type of the functional group. You should not have any confusion about your acid, halides, acidic anhydrides, all these things, right? So you should remember this one. Another way of writing this functional group is this one, CO times 2 oxygen, and this is the vacant valencies, right, on this 2 CO group, right? And this oxygen is which is outside this parenthesis, it is actually this oxygen which is connecting these 2. Okay, general formula for this is CO, single bond O, CO, and this valency is connected with the R dash, and this valency is connected with the R. So when these 2 are same, right, then you should write R. And see, when I am writing this R prime, or right, so R prime means it is little different from this one, and instead of R you can also put aryl group here as well, right? So this is very, very important to identify the functional group. So how we can write the IUPAC nomenclature of this compound? So the IUPAC nomenclature of acidic anhydrides would be just like that, alkanoic anhydride. So the name would be, IUPAC name would be alkanoic anhydride. Anhydride would be common. Alk is for the word root, right? And oic is for the acid. And since they are the anhydrous form, that means they lost the water molecule during the formation of the anhydrides. So we'll write the anhydride. And now say this is your first example, CH3 CH2 C double bond O, O C double bond O, CH2, CH3, this is acetic anhydride. And if you clearly focus on this one, then you can see this particular part, carbon double bond oxygen as well as the alkyl group, which is present on the right hand side, is exactly identical to the group which is present on the left hand side. So this anhydride is basically symmetric anhydride. Please remember, it is symmetric anhydride. Okay, so when you have the symmetric anhydride, then you should write the name of your this part which is present on the either side of the oxygen only once. You will write this part only once. Okay, that means how we can see, and sometimes what in modern organic chemistry, what we do generally, we actually avoid to write this much of bigger structure. Instead, we use this bond line notation. So this compound which I have written here and that compound, they are the identical one, and this is carbon 1 which is your CH2, and this is CH3 which is this carbon. Generally in the bond line notation we don't write any hydrogens attached to it, and every vertices or every end represents one carbon. So if you want to write the IUPAC name of this particular compound, so you should select the longest chain. Say this is carbon number 1, this is carbon number 2, this is carbon number 3. Similarly, this is carbon number 1, this is carbon number 2, this is carbon number 3. When you number the organic compound, you will always give the highest priority or the lowest number to this carbonyl carbon which is connected to the oxygen. So you should write 1, 2, 3. This is the correct way when you move from left to right. See, if you do like that, say for example, if you do like that 1, 2, 3, then it would be wrong, right? When it is wrong, so I am not writing it, I am removing it, right? And how we can write the IUPAC name? Alkanoic anhydride. Alk means word root, right? So in my earlier lectures, I have already explained to you what is the word root actually. Word root is the total number of the carbon present in the longest chain. Okay, so in that case, you can see total 3 carbons are there. 1, 2 and 3. When these 3 carbons are there, so we will write prop for this one, P-R-O-P, prop, right? And all these 3 are connected with the single bond. That means primary suffix means the bonding present between the carbon atoms, right? So you will write all carbons are connected with a single bond, so you will write propane, and then you will write oic. So it is propanoic. This propanoic is actually coming from this alkanoic. Alk is for prop, since 3 carbons are there. Ane is the bonding, which is the single bond between the all carbon atoms, right? And oic is the IUPAC way of writing this. So this is alkanoic, and then you will write the anhydride for this one. Alkanoic anhydride. So this would be the correct IUPAC nomenclature of this one. Whenever you have the symmetrical type of the anhydride, then you will write this alkanoic part only once, right? You cannot think in that way. One propanoic is there, another propanoic is there, so we should write dipropanoic. No, it will become wrong. Whenever you have the symmetric anhydride, then you will always write that alkanoic part once only, followed by the anhydride, and these 2 spellings would not be connected. There would be the gap between the 2. I hope this is quite understood now. Now on the same background, if you think in that manner, this is carbon number 1, this is carbon number 2, again this is carbon number 2. So again it is a symmetric anhydride, because on the either side of the oxygen only 2 carbons are there, and for 2 carbons, we write eth, and then this is ane, and then oic anhydride. So this is IUPAC name of this compound is ethanoic anhydride. It is quite simple. The only thing is that you should remember that it is, you should be able to identify, first of all, you should be able to identify the functional group, and then you should you should be able to recall that, okay, this is anhydride, so the IUPAC nomenclature would be alkanoic anhydride. When you remember these things, then it would be quite easy for you to solve the problems. Now this is my problem number 3, this one. Okay, so how I can do for this one? Say this is carbon number 1, this is carbon number 2, this is carbon number 3, this is carbon number 1, this is carbon number 2. So since on the either side of the oxygen number of carbon atoms are different, that means these anhydrides are unsymmetrical. Unsymmetrical. Please remember, this is your unsymmetrical anhydride. And whenever you have the unsymmetrical anhydride, then it is your duty to write both the alkanoic part separately, and while writing the alkanoic part, you will always follow the alphabetical order. How alphabetical order? You know, whenever your long chain is having 2 carbons, you use eth for this one, and whenever you have 3 carbons, you use prop for this one. And you know, in the alphabetical order, E comes first. After E, your P will come. That means in alphabetical order, E comes first. So you will write ethanoic part first. So for ethanoic part, then you will write here ethanoic. This is ethanoic. Once you're done with the ethanoic, then it is your duty to write that part, because it is unsymmetrical alkene. 3 carbons are there. So you'll write propanoic, ethanoic, and propanoic. And there should be difference. There should be a gap between the two oic part, ethanoic and propanoic. And then after that, you left with the anhydride. So the IUPAC, correct IUPAC name of this compound is ethanoic propanoic anhydride. In the similar way, you can write here carbon 1, carbon 2, 1, 2, 3, 4. So for 2 carbons, you will use eth, and you are doing alkanoic, that you are doing a nomenclature of your acetic anhydride, and the IUPAC rule says that you should write oic, so it is ethanoic, and after that butanoic. Why butanoic? Because 4 carbons are there, and 4 carbons we use the word root butanoic, right? And then you will write anhydride. So this would be the IUPAC nomenclature of this compound. Okay, now we can move little further and see little bit more complex examples. Say this is carbon 1, this is carbon 2, and that is carbon number 3. Say if you want, then you can convert. If you are new, if you are beginner here and you are not able to understand how actually we are converting, how we are doing this nomenclature, so you should convert these things into the proper condensed formula. So how we can convert this in the proper condensed formula? I am explaining for you for this particular example. So first, say this is 1, this is 2, this is carbon number 3, and that is carbon number 4. However, you can make this 3 and this 4. This will be exactly same with that one. If you write this carbon as 3 and this as 4, then it will also completely fine, because all the numbers will give you the same results. So how you can convert this into the proper condensed formula? So on the left hand side, total 4 carbons are there. So you will write 1, 2, 3 and 4, right? And then you are having your oxygen, and the right hand side you are having 3 carbons. So you will write 3. Okay, connect all of them with the single bond. Okay, and you can see after oxygen, see you can number them. Say this is 1, this is 2, this is 3, this is 1, this is 2, this is 3, this is 4, right? And then after that, what you can do, you can see here at carbon 1 on the right hand side, this is carbonyl group. So what you can do, you can convert this into the carbonyl, right? And on the left hand side, this one is basically again a carbonyl. So you can convert this into the carbonyl. Okay, and you can see on the carbon number 3rd, you are having 2 methyl groups, 1 and 2. 1 carbon represents the methyl group, Okay, so you can put two methyls here, CH3 and another CH3, and then finally you can complete the valency because carbon is tetravalent. So this carbon is having only valency of 1, this valency. So you must make this carbon tetravalent. For this you will add hydrogen to make it tetravalent. So you will add 3 hydrogen here. So the valency is 3 and 1 4, and for this carbon 1 and 2. So it is 2 valency short. So you will write CH2 here. This carbon is tetravalent, 1, 2, 3 and 4. This oxygen is bivalent, 1 and 2, very fine. This carbon is tetravalent, 1, 2, 3 and 4, very fine. This carbon is bivalent, 1 and 2. So it is your duty to put CH2 here in order to make it tetravalent, right? So, and this carbon you can see here, this is again tetravalent, 1, 2, 3 and 4, but this is monovalent. So you should write CH3 here. So with the help of the little practice, you can easily convert your bond line notation into your condensed formula and condense into the your bond line notations. Okay. Now, if you understood this one, then it is quite fine. Then we can write the IUPAC name of this particular compound. So how I can write the IUPAC nomenclature of this compound? See, these are the 3 carbons. That means it would be your propanoic, right? It would be your propanoic. Okay, and on the you can see here on the left hand side 4 carbons are there. So this is your butanoic. Okay, in the alphabetical order B comes first, so you will write the butanoic, but that butanoic part you can clearly see at carbon number 3 it is substituted with these 2 methyl group. So how you can write 3, 3 dimethyl and then butanoic. Okay, and then you will write propanoic, and after that anhydride. So the correct IUPAC nomenclature of this compound number 5 is 3, 3 dimethyl butanoic propanoic anhydride. I hope you understood this. Now I am moving to the next problem, which is my problem number 6. And for problem number 6, I'll write the IUPAC name of this compound. So this is carbon 1, this is carbon 2, this is carbon 3, this is carbon number 4. This is 1, this is 2, this is 3, this is 4, and this is 5. Okay. So this is butanoic. The right hand side part is what? Butanoic. And left hand side part is your pentanoic, because 5 carbons are there. Okay, right? So you will write the alphabetical part B. See, in the alphabetical order B comes first, so you will write the butanoic first, and you are also observing that, you are also watching that at carbon number 3 you are having the bromine substitution. So while writing the butanoic part, you will write 3-bromo. Okay, and then your butanoic. And then you will do the same thing for the left hand side part. In the left hand side you can see here, this is your side chain, and that methyl is also side chain. It is not a part of the longest chain. Okay, that means carbon 3 and carbon 4, this is carbon 3 having methyl substitution, carbon 4 having chlorine substitution, but alphabetically C comes first, so you will write this chlorine first. So how you write? 4-chloro, right? -3-methyl. Okay, and 5 carbons are there, pent. All 5 carbons are connected with the single bond, so pentane, and it is oic, and then you will write its name anhydride. So the correct anhydride. So correct IUPAC name for the compound 6 is 3-bromo, butanoic, 4-chloro, pentanoic, and pentanoic anhydride, right? 4-chloro, 3-methyl. I should write 3-methyl as well. So this is 3-methyl, right? So this is how you can write the IUPAC nomenclature of this compound. Now this is my problem number, you can see this is my problem number 7. So this problem is looking like little bit tricky. So whenever you have such kind, whenever you have been given say this kind of the structure, so don't hesitate to convert it into the simpler formula or the condensed formula. So how we can convert this into the condensed formula, right? In the center oxygen is there, and on the either side you are having the carbonyl functionality. Please remember, when it is your anhydride, that means both the sides of the oxygen will have the carbonyl functionality. And then you see here this CO is 2 times, so one CO and another CO. Oxygen is 1 time, so I have written here. Now CH2 is 2 times, right? When CH2 is 2 times, so you will connect this with the CH2 and then this with the CH2, and then you can see this chlorine is also twice, right? So when it is twice, so you will write Cl here and this is Cl here. Now this is something very, very important, very important. Now in that case you can see here this part actually is not that simple. It is little bit complex due to the presence of this chlorine, and this is also the little bit complex due to the presence of the chlorine. But both the sides, left hand side and the right hand side of the oxygen, are similar, but they are complex, right? So when they are not actually simply your hydrocarbons and one of the carbon is substituted with the chlorine, then and both are same, then you should use bis for this one. It is very, very important. Please remember, it is very, very important. So since the complex part is present twice, so you will write the bis for this one, and then you do the numbering 1 and 2, similarly 1 and 2, and at 2 position you are having the substitution of the chlorine, that means 2 dash chloro, and only 2 carbons are there, so you will write ethanoic, okay, and after ethanoic you will write anhydride, okay. See, in the earlier case, if I go back, you can see here this ethanoic and ethanoic, they are present only 1 time. So simply IUPAC says that write that alkanoic part only once, because they are the simple hydrocarbons, okay. But when this part is substituted with the chlorine, then for since it is present for the 2 times, so you will write bis for this one. Bis represents this 2 chloro ethanoic part is present 2 times, right? And then you will write the anhydride. This is how you can do the IUPAC nomenclature of this particular compound, okay. I hope this is quite clear. Now this is again quite simple. So, and if you want, then you can easily convert it into the more simpler or recognizable form, right? This is CH3, and then on this particular side this is oxygen and then your hydrogen, okay. And then you see this is carbon number 1, this is carbon number 2, this is carbon number 1 only, okay. So alphabetically ethanoic comes first, so you will write ethanoic for this one, okay. On left hand side you are having only 1 carbon, that means meth, so it would be your methanoic, ethanoic, and then you are having your methanoic, and after that you will have the anhydride, okay. So this is the correct IUPAC name of this compound. Now the compound number 9. See, this one is quite tricky actually. See, this is cyclic anhydride. This is cyclic anhydride, and when you see when you know about little thing about your heterocyclic compounds. What are the heterocyclic compounds? In which a cycle carries the heteroatom. That means apart from the carbon atom, at 1 or the 2 position you may have the other element, other atom as well, like oxygen, nitrogen, sulfur, etc. So it's a heterocyclic compound, and when it is a heterocyclic compound, it is furan, basically 5-membered compound in which there are no double bonds connected with the oxygen. That compound is basically furan, and since double bond is not there, right, so hydrogens actually are hydrogen have saturated this double bond. So how you can write the IUPAC nomenclature? So you will write the dihydro for this one. Dihydro. Why dihydro? because earlier, say for example, you are having double bond here, but in the latest example, this double bond is vanished from here, and to complete the valency of the carbon, this carbon and this carbon will have the extra hydrogen. That's why dihydro we will write here. So it is your dihydro, and after dihydro, 5-membered ring containing with the oxygen. So we will write the furan for this one. Furan, and at position number 2 and 5, you are having the 2 carbonyl functionality, that means ketone like functionality. So it is a dione. It is very, very important to note that. Okay. So how we can do the numbering? Say 1, 2, 3, 4, 5. So at position number 2 and position number 5, you are having the carbonyl functionality, which is ketone here. So it is dione. So basically it's a heterocyclic compound. And for the nomenclature of the heterocyclic compound, I will cover, or I will upload another lecture, right? So right now, if you find little bit difficult to understand this one, you can skip. Okay, I'll explain the heterocyclic compound separately, but if you know little about heterocyclic compound, then you can understand the rule says that this would be written like that. Okay, right? And then you can see here my next, this is there my compound number 10. So again you can see it is quite easy. This is carbon number 1, and this is the substitution of the cyclohexane ring. This is carbon number 1. This is again the substitution of the 6-membered ring, and all these are same. There are no substitution on it. So you can simply, however, they are complex, not very simple one. So in order to show the complex nature, you will write bis for this one. Okay, and this cyclohexyl, you will write cyclohexyl. Okay, and then you will close bracket, and then you will write methanoic, and then you will write anhydride for this one. So this is how you can write the IUPAC nomenclature of this one. And if you check for this one, say this is carbon number 1, and again this is carbon number 1. Okay, and you can see here, if you start numbering, see so then you can give number 1 to this one, 2 to this one, 3 to this one, 4 to this one, 5 and 6. Similarly you can do here 1, 2, 3, 4, 5, 6. So rule says that first of all you will write the substituted part. So it's a complex thing on the either side of the oxygen or the carbonyl group. So you will use bis for this one. IUPAC rule says that. And you can see here at the carbon 2 and carbon 4, bromine substitution is there. So you will write 2,4 dibromo. You will write dibromo for this one. Okay, and this is the derivative of the benzoic acid, right? So this is the, see what is benzoic acid. I hope you know what is benzoic acid. Benzoic acid is whenever your benzene is having COH. Whenever you have the two type of the benzoic acid, two benzoic acids, so here OH and H will remove from here, and you form this anhydride type of thing. So basically this is benzoic anhydride. So you'll write the 2, bis 2,4 dibromo, and then you will write the benzoic, and then you will write the anhydride, benzoic anhydride. Okay, so this is the IUPAC nomenclature of this particular compound. Now if you move little further, okay, now finally 3 questions are left. So how we can solve this one? Say now this problem number 12 you can see here. So this is carbon number 1, this is carbon 2, this is carbon 3, this is carbon 4, and this is carbon number 1, which is having the substitution of the benzene ring. So how you can write the IUPAC name for this one? First of all, you will write the right hand side part, which is but, and ane is there, so you will write the butanoic for the right hand side part. That means for this particular part you will write the butanoic. Okay, and then you can see here, if you see on this carbon number 1, this phenyl substitution is there. Okay, then you will write 1-phenyl, and then you will write methanoic anhydride, methanoic anhydride. So this is the correct IUPAC name of this particular compound. Okay, so this is how you can write the name. So you cannot, you will not use here benzoic anhydride. Okay, so this is basically the derivative of this one. This is quite simple now. And then you can see here now this compound, which is my problem number 13. What it says that my problem number 13. Again, see, this is benzene ring. See, earlier we have solved a problem of this kind. Where? Yeah, not this one. Okay. Right. Okay. These two problems I am discussing. So again, you see it's a heterocyclic of the heterocyclic type of the compound. So for this you will write iso, okay, and then benzo, and since it is the derivative of the furan, so you'll write the furan dash 1,3 dione. This would be the IUPAC name, 1,3 dione. This is how you can write the IUPAC nomenclature of this one. Or if you want, then you can skip this one because I will explain. However, this is correct. This is not wrong actually, mind you. This is not correct. This is not wrong. This is correct, but it is a heterocyclic compound. Okay, so that's why you can write like that. Similarly, you can go for this one, right? But if you find these things little difficult to understand, especially when you are a beginner and you are studying in your class 11, then it would be quite difficult for you. But for others like graduates or postgraduates, these things are quite simple. So this is how you can do the IUPAC nomenclature of the anhydrides. I hope you understood the lecture. So if you like the lecture, right, so please share with your friends also, and don't forget to like the video and subscribe the tetrahedron chemistry classes to learn the various important concepts of the chemistry. Okay, so that's it for today. Thank you. Thanks for watching. Bye bye. Take care.